Hello teacher and hello students. This is mathematics tutorial series which is organized by Oromia Education Bureau. I'm Garuma Abdisa from Matu University, and our today's topic is about transformations of the plane. And there are some symmetry operations which are about translation, reflection and rotation. And the purpose of these symmetry operations is to transform a point such as A of x comma y to another point which is called the image of that point into A prime, x prime and y prime. Let us see them one by one. First, translation. Under translation, each point is moved to another point which is fixed at a distance in a given direction, and such a motion is an example of region motions that you can see here. For example, this point is moved to the left and then 2 pointers to up. So this is translation. Translation is just like moving a point from its original position to another place. As you can see here also, here this rectangle is being translated from its original position to another new position, and now it is also being translated to another position. This is an example of translation. And how much it is moved from its original place is determined by the translation vector, and that translation vector t tells us how many units in the x and how many units in the y the object has to move. Look again, this triangle is being translated from this quadrant to the first quadrant, and this is an example of translation. We are moving by keeping every orientation of the triangle, but we are simply translating or moving it from the original place to the other place. So that is what is meant by translation. One of the symmetry operations is reflection. Reflection is another type which is defined by its axis or line of symmetry, that is the mirror line, which is called the mirror line. And that mirror line makes a reflection of our original point to another point. For example, each point P is mapped onto a new point which is P prime, which is called the mirror image of it, of the line P in the mirror line, such that this line P prime is perpendicular to the mirror and such that their distances are preserved. Reflection is a symmetry operation that preserves distance. Another key point here is that all points on the axis are invariant. If there is a point on the mirror itself, that point will remain invariant, means it is not going to be changed by the symmetry operation which is called reflection. Look, this one, this is an example of reflection where this axis that you see is acting as a mirror. Whenever we are reflecting from this to the other side, this axis is acting as a mirror, and when we are reflecting it from here down, like this one, the x-axis is acting as the mirror. Look again this point. This is the original point, which is A. This is the original point, and then this is the image. This A prime is called the image of the original point A. So the point 2, 5, it is final destination after reflection. We have got a new point, A prime, which is 5, 2. So our purpose in this case is, given the first point, that is 2, 5, then how can we calculate and arrive at the new point, that it would be 5, 2. How do we get the new point? So that is the purpose of this topic. For example, if the original point is A of x, y, then our new point is going to be x prime, A prime of x prime, y prime. So these are required, but these are given. So that is the way we are going to deal with the problem. Here are some formulations. For example, if we have x-axis and y-axis, this is our line. This line L is a line which is acting as a mirror line. And with the help of this mirror line, I have one point that is the object A of x comma y, that is my object point, and this is my image. The image is A prime of x prime comma y prime, and this line is at radius r, and after reflections about this line, this is a new point which is A prime of x prime comma y prime. So our target is, given these two, how do we calculate these 2 points, x prime and y prime? And here are the formulations. The slope of such line, m, is always given by tangent of the angle, because this red line that you see is at an angle theta. This is at an angle alpha. And because angle of reflection and the angle of this original angle, that is this angle between the red and this blue color, is theta minus alpha, the same has to be after being reflected, because the angle of reflection and the angle at which the image is created has to be the same. Both are theta minus alpha. So altogether, this whole angle is alpha plus theta minus alpha plus theta minus alpha, which will finally become 2 theta minus alpha. So having this in mind, I want to decompose this one into y, and this up to here as x. And the same is true for this one. This will be y prime, and up to there it will be x prime. And that is the way we relate those coordinate systems into its components. So according to this, the angle that you observe here, x is r cosine alpha and y is r sine alpha. And as I told you, the final image here is at an angle of 2 theta minus alpha. So when we decompose that into its component, x prime is r cosine of 2 theta minus alpha, and y prime is r sine of 2 theta minus alpha. And then with the help of sum and the differences of cosine and sine identities, we can rewrite x prime as r into cosine of 2 theta cosine alpha plus sine of 2 theta times sine alpha. And grouping together similar terms, this is already what is here, and that is in turn x. So that would be x times cosine of 2 theta for this part, and for r times this side, that would be r sine alpha, that is already y. Then we replace it by y. So x prime is simply x into cosine of 2 theta plus y sine of 2 theta. With similar argument for y prime, r sine of 2 theta minus alpha is expanded in this way, and substituting the values for x and y, we can finally write y prime as x sine of 2 theta minus y cosine of 2 theta. So if you are not sure on how to make a trigonometric expansions like sine of theta plus alpha and also for cosine, here is an identity for you. Have a look at it, and this is what we have used in the derivations. Reflections may happen through an axis which passes through the origin, in which case the equation of our mirror line is written in the form of y is equal to mx, or next we are going to see the case where this line will have a y-intercept, y is mx plus b form. We will talk about that next, but let us get started with this simpler case in which our line, which is the mirror line itself, is passing through the origin. By then, we directly use the formula that we have derived a while ago, which is simply x prime is x cosine of 2 theta plus y sine of 2 theta, and y prime is x sine 2 theta minus y cosine theta. And this is something we have obtained from the derivations that we have made a few minutes ago. So if we wanted to write it in a matrix form, we can write this in this way. They are identical, and you can multiply this one by, you multiply cos 2 theta by x, and sine 2 theta by y, and sine 2 theta by x minus cosine 2 theta by y, and then you will simply get this one. They are same. For a mirror line which passes through the origin, if this is given, this is going to be the required. And here are some trigonometric identities that will help us to relate, because if an angle is given, whenever this kind of line is given to us, y is equal to mx, this is the slope. This m is taken as it is slope, so that slope is m is equal to tangent of theta. And with the help of these trigonometric identities, we can get cosine of theta. And because cosine of theta is not appearing in our formula, but rather cosine of twice theta, so we have to have a way to convert this cosine of a single theta into cosine of twice theta, and that is the way we have to convert our angles in such a way that finally we can plug into our formula not cosine of a single theta, but twice of it. The same applies for sine, and we have to use the formula that you see here. After doing so, if we want to find equation of the line, slope of a line that passes through 2 points, P1 of x1, y1, and P2 of x2, y2, if that is given, then the slope is m is equal to y2 minus y1 over x2 minus x1. That is the formula for calculating slope. The point slope equation of a line that passes through any point P1, x1, y1, and with the slope m is given by y minus y1 is equal to m into x minus x1. This is a well-known slope formula. Another one is the slope-intercept equation of a line with slope m, and the y-intercept b is y is equal to mx plus b, and this one is the y-intercept and this one is the slope. This is equation of a line having slope and y-intercept. And equation of a circle with center hk, if this is center of the circle, and radius r is given by this formula. This is equation of a circle. The formulas that I gave you here are to guide you whenever you want to reflect from one point to the other, and on the way, if you wanted to calculate the corresponding equation of line or the corresponding equation of a circle, this is a quick reminder of what you have to pass through as you do that kind of calculation. There is an alternative way to derive reflection that passes through a line about the origin, that is y is equal to mx. We can write it in this way. If this is an angle theta, this is our mirror. This distance from the point up to here must be the same after the image is created. Both of them are d. And if we have two parallel lines crossed by the transversal, this angle and that angle must be the same. And these two triangles are similar and they are congruent also. The consequence of that is these two angles has to be the same. And we take this as x comma y. Therefore, this point has to be x, and this point is x prime comma y prime. So this is x prime, and that point is y prime. And for this one, this point is y. So if we pick up this triangle so that it will be clearer for us, if this is y, so this has to be y prime minus y, that is already this one. And this distance is x minus x prime, which is already there. So using sine and cosine law, we can rewrite this formula in this way. And by rearranging and also taking advantage of the formula for the perpendicular distance d of a line, if this is a generalized equation of a line, ax plus by plus c is equal to 0 form. From that line, if you wanted to find a distance from this line to another point x1 comma y1, which is given by this formula, this is a formula between a given line and a given point. Thus, in our case, we are using this formula, and therefore, this is written as mx minus y is equal to 0. That is simply coming from y is equal to mx. So it means that mx minus y is equal to 0. So this is my a. 1 here minus 1 here is my b. C is 0. Then I will directly substitute it into here to write it in this way. And by simplifying with the help of this trigonometric identity, we can simplify this equation to get d is equal to x sine theta minus y cosine theta. This is just an alternative derivation of how we can arrive at similar formulas that we have already done from a different perspective, so that you can have a chance to prefer which one will be simpler for you to understand. It turns out that after plugging in those values and simplifying, from the diagram, we can directly write x prime is x minus 2d sine of theta. And we have already got a formula for d there, and by substituting that back into the d here, and by simplifying, you will get x prime is equal to x cosine of 2 theta plus y sine of 2 theta, which is exactly the same formula as I have derived previously. The same applies for y prime, in which case also you substitute this d, which I have shown you before, and finally you get y prime is equal to x sine of 2 theta minus y cosine of 2 theta, which is also exactly the same. So this is the same result as before, means previously we made a derivation from a of x comma y that maps to another point a prime of x prime comma y prime, and it turns out that the formula for x prime and y prime is given by this formula, and we have derived it, and this derivation that we have made a while ago is an alternative to that one. So now if rather our line equation doesn't pass through the origin, but rather it will have some sort of y-intercept. This is y-intercept, y is equal to mx plus b form. The only thing we need to do is for a reflection in a line through y is equal to mx plus b, use these steps. The first step is translate the plane by 0 minus b, so that the crossing point of the line on the y-axis is mapped onto the origin. The second step is reflect in this line through, or this is simply the translation vector, 0 comma minus b. Thirdly, translate it back with the translation vector 0 comma b. This is written in the column matrix form to get the standard form. So it turns out that finally the very general formula for a reflection is x prime y prime minus b is cosine of twice theta sine 2 theta, sine 2 theta minus cos 2 theta here, and you can simply multiply this with that, then this with this, and then this one with this, and this one with this, and then finally you get this one. So this is a very general formula that you can use. This formula is general formula. It applies if our mirror line passes through the origin or not. So x prime is x cosine 2 theta, y minus b here, you simply add this one. If it is passing through the origin, this b would be 0. So for comparison, this one is for reflection about the origin, and this one is for reflection very general, that is mx is equal to plus b form. If you simply stick to this one, it also includes this one. So here is an example demonstrating what we have done numerically. Find the image of the point 4 comma 0 when reflected about the line y is equal to 2x plus 1. And as I told you, always the coefficient of x, which is 2, is always the slope, which is the slope, m is equal to 2, which is tangent of theta. Because tangent of theta is always the opposite divided by adjacent side, so this is opposite over adjacent is 2 over 1. Then 2 squared plus 1 squared is root 5 here. And then sine is opposite over hypotenuse, so that is 2 over root 5. Cosine of theta is adjacent over hypotenuse, that is 1 over root 5. You can directly plot a triangle from this given section, and from that you can infer what sine and the cosine has to be. Then, because the sine and the cosine angles that we have in our formula have double angles, we have to convert this sine single angle and the cosine of single angle into 2 theta and the cosine 2 theta using these two identities. And then finally sine of twice theta is 4 over 5, cosine of 2 theta is minus 3/5. Then we can also possibly use this one in order to convert, directly obtain sine and the cosine from tangents directly from this one. Then since we already have sine of 2 theta and the cosine of 2 theta to be 4/5 and minus 3/5 respectively, and the y-intercept to be 1, the only thing we are left with is to directly substitute those values into our formula, and then it turns out that x prime becomes negative 16/5 and y prime is 18/5. So when we reflect the point A of 4, 0, the final image point will be this one, and that is the way it is done. Reflection of a line through another line. How do we reflect one line about another line? The straightforward way to do this kind of problem is simply to pick up any 2 pointers from one of the lines that is not the mirror line, but the line from which that you wanted to reflect. Then you pick up 2 pointers, and then you will find the corresponding images of those 2 pointers, and finally, using the two-slope intercept form of equation of a line, you can directly find the equation of that line finally. And this is the argument showing what I have told you. So, for example, first we pick up 2 pointers, b1 of x prime, y prime, and the b2 of x2 prime and y2 prime. Then first we have to find the slope with the help of this formula, y2 prime minus y prime over x2 prime minus x1 prime. And then equation of that line has to be given by this, or possibly by this. Using any one of them, you can directly calculate the line. That is the general roadmap upon which you have to go through in order to tackle that kind of problem. This is equation of line, y minus y prime is m into x minus x prime, or y minus y2 is m into x minus x2 prime. Both of them will yield the same result. And here, for example, if we have different lines that will have a possibility to meet somewhere, this is S and this is S prime, this is our mirror, this is the mirror, these 2 lines may be parallel. If 2 lines are parallel, means they will have equal slopes, means m1 is equal to m2. The slope of this one and the slope of this one are same if they are parallel. But if these 2 lines are perpendicular, means if 2 lines are perpendicular to each other, making 90 degree between them, if the slope of this one is m1, if the slope of this one is m2, then the product of m1 times m2 is always equal to -1. Example, find the image of the line S is equal to 3x plus y is equal to 2. When it is reflected through the line, y is equal to x plus 4. This is the object, and this one is the mirror. So the line S can be written as this way, and the slope of the line is and the slope of this line is 3, because we can rewrite it so that the slope will be m is equal to 3. And the slope of this line is the coefficient of x, which is m is equal to 1. Because the 2 slopes are not equal, the 2 lines will meet. Now let's choose any 2 pointers from S. For example, we can choose any 2 pointers. One of those pointers could be b1 of 0, 2, and the other point could be 1, 5. That is, if I plug in 0 there, this, by the way, this one is can be written as y is equal to 3x, y is equal to 3x plus 2. Y is equal to 3x plus 2. That is the way this can be written. That's why the slope is this 3 already. And then if we directly plug in 0 here, then we get 2. That is 0, 2. If I plug in 1, 1 times 3 plus 1. If I plug in 1, I will get 1 times 3. 3 plus 2 is 5. So I will get b2 of 1, 5. So I already picked up 2 pointers, and then I'm going to make a reflection of those 2 pointers about the given line with the same procedure that I have shown you before. So here are my angles from the slope. I can directly write this triangle, and correspondingly I can obtain the sine values and the cosine values from that one, and then we can directly find an image for one of those lines. For example, in this case, if I first choose B1 is equal to 0,2, so the image of that will be -2 and 4. We directly substitute the values into the formula and we get -2,4. So my point B1 x prime comma y prime now is mapped to -2,4. With the same procedure, the second point also, which is B2 1,5, is mapped to itself, also 1,5. Means the image of 1,5 has now also become 1,5. By the way, if we get this kind of point, it means that point is invariant. It must be, it is an invariant and a reflection. That is, it must be on reflection line. You can justify this by simultaneously solving the two equations that, and eventually you will find the point is 1,5 to be an intersection point of the two lines. Furthermore, the choice of the points B1 and B2 does not affect our final result. It is up to you to pick up any two points, and finally you will get the same result. So once we got the two image points for B1 prime and B2 prime, that is our slope, and from that I can get the slope to be 1/3. Now the equation of the line S is given by directly by this formula. You simply plug in the formula I have discussed before, so you get y to be this one. Or preferably, if you want to use the other point, that is the second point, you will also get the same result. Same result is always obtained, whichever point you use. This is a general reflection formula. Probably this would be the most important one. This one is very straightforward, and it is free from sine and the cosine of angles. We can directly find the image of A of x comma y without having angles, and this is the midpoint, and the midpoint is always obtained by adding x plus x prime over 2 and y plus y prime over 2. That is the midpoint, and the equation of this mirror is given by this formula, and because this midpoint is also a part of the mirror equation, as it is a part of this line also, so that midpoint must also satisfy this equation because it is a part of it. This point is common to both lines, so it means that I can directly plug in that point into this one, but before that, if we rewrite this equation y is equal to minus a over bx plus c over b, we can rewrite this one in terms of this one, so that I can directly see that the slope of this line is minus of a over b, and because they are perpendicular to each other, and the slope of this line is b over a, so that b over a times minus a over b would be minus 1. So this is the midpoint, which is plugged into this formula, and then we can directly write this one, and then from this I can rewrite this equation by multiplying throughout by 2, so that x prime and y prime would be to the left, and the rest would be to the right of the equation. I can write this equation as equation 1, and from y minus y prime over x minus x prime, that is an equation which is obtained from this equation of this line. For example, y minus y prime over x minus x prime, that is its own slope, which is this one. From that argument, you can directly write this one, and by rearranging this formula, you can have this as second equation, and then by solving for x prime and y prime, using, for example, you can use Cramer's rule, so that life would be simpler, and then after doing that, you can directly get x prime to be equal to, you can get x prime simplified in this way, and then finally that is my x prime. I can get it this way. It's much simpler. You simply plug in everything you have into the Cramer's rule like this. If we have ax1 plus b1y is equal to c1, a2x plus b2y is equal to c2. If x and y are unknown, they can be evaluated by these two formulas that is coming from Cramer's rule. In the same way, x prime and y prime are unknown, x prime and y prime are unknown. The rest, everything is known, and we directly plug into that one. And then finally, you directly get x prime to be this one. And with a similar way, y prime can be calculated to be this one. And these two formulas are very straightforward to use. This is general formula for reflection. You can always use this one. This is a general formula for reflection. Find the image of the line. S is equal to minus 3x plus y is equal to 2. That is the formula that we have done previously. I want to directly now plug into these two formulas without having the angles to be calculated. And it turns out that with only very few steps, when we substitute for x prime, which is x in our case is, for example, these 2 pointers, x comma y, because now I'm restricting on this point first, because I'm now calculating for this point. We have everything here. We directly substitute into this one, you get minus 2. And for y prime also 4 by direct substitution. So we got the same result as before, but within a very few lines of steps. Similarly for y prime, by directly substituting the values that I've showed you, but this moment for this point rather than the other one. So we get also for y prime, we directly substitute in the values here, the same values as before, and then you will get y prime to be 5. So we are getting the same result as before, but this is much pretty simpler than the previous approach. So this brings us to the end of this very important topic. Thank you very much, and have your own time to practice.